Hi, everyone, and welcome to From Outage to Opportunity, how to strengthen your web applications against global cloud failures. I'm Joey D'Antoni I'm a principal cloud architect at 3Cloud, and I'm here with my colleagues, John Morehouse and Denny Cherry from Denny Cherry Consulting. Denny is the CEO of DCAC, and he's a Microsoft Data Platform and Azure Networking MVP. I am a principal cloud architect at 3Cloud. I'm also a Microsoft Data Platform and Azure Compute MVP. And John is principal consultant at DCAC and a Microsoft Data Platform MVP. And I think Denny and I are still V experts, maybe.
I believe so.
I'm not. I lost that
Yeah.
one.
What we're going to talk about today is how some of these cloud outages will happen and how our goal is, kind of resilience and building more robust applications. After the front door outage, I took some time to start to build, a highly resilient web application that we're going to talk about throughout the app. It's called sketchyracingsponsors.com. Don't laugh, I had the URL. So, but what we're going to focus on is kind of architecture and Azure networking. We have a lot of strengths between the three of us in that space, but we're also pretty strong in the database space, and that's a lot of what we work on. But beyond databases, I think we all kind of work on high availability in systems. We talk about security, web application firewalls, performance, and operations, because that's all going to apply here. Denny, John, you want to say anything before we kind of dive in?
Yeah, I mean, I'd say the big part of the cloud is, the fact that there are all these random little pieces that are floating out there that we can bolt onto our environment, that can end up kind of screwing things up, and we expect them to just work, and they don't always, and it can be annoying and problematic for the apps.
John?
My only comment is the cloud is not always on, and outages happen, right? We've experienced this. We do presentations, and I talk about the rapid backhoe, where some operator on a construction piece of equipment has cut the wrong cable, and data centers go offline, and things happen. And I guess that's a misconception. Like, I think even in 2025, we still talk to individuals who think the cloud is always on, and it's not the case.
Yeah, it's kind of interesting because in the early days, back of SQL Azure, Denny, don't you remember the guidance was always just assume you're going to lose communication with your database and write your app to handle it?
That was the recommendation back in the day, and I think we've gotten away from that a little bit. It's problematic.
Yeah. The cloud's gotten a lot more robust, and I write a column at Redmond. I wrote about this front door outage a couple months ago. Actually, excuse me, it was the first one. So we're going to get into these outages in a minute, but Microsoft has had two outages around front door, and I do a lot of tracking because it's something I'm pretty interested in like the history of cloud outages and what how they take place and what services they affect. And what's really kind of interesting is almost universally cloud outages are regional in nature, in that a region will go down, typically some core set of services kind of entirely there. But what we don't see in what we see in these outages between Microsoft and Cloudflare, we're dealing with global services and not regional services. And you want to explain a little bit about what that means, Denny?
Yeah, so a regional service is fairly straightforward to understand. Is the thing you're looking at is pinned to a specific region. So, like, if you spin up a virtual machine in your favorite cloud, I'll pick on Azure because I know it the best. So if you spin up a VM in Azure in North Central, for example, that VM will always live in North Central. Whereas if you look at a global service like, say, Microsoft Front Door, that's going to be everywhere all at the same time. So if you make a change in, to the front door config, that change is pushed out across the entire world, and that change is then available, kind of everywhere, for you to see, and it affects everything all at once worldwide, and it's pushed out and stored in all the various regions throughout the cloud environment instead of just in that one specific place like a VM is.
And more importantly, when Microsoft makes changes to the service, it's pushed out globally instead of regionally. There's this notion that you hear about, and I may have written about, but it's called a ring deployment model. I think some of that goes back to what the old IBM like security layering thing.
Yeah, that's the old IBM version of, red, green, blue zones, and
Yeah.
they deploy to one at a time and stuff like that.
So, and I can really only speak to Azure, but I'm sure AWS does something very similar, and probably Cloudflare. When changes roll out, they'll roll out to Microsoft's internal regions first. They have some internal regions that are not visible. Then they'll roll out to some specific regions, and basically at every layer, they're looking for rapid failure. And if there's failure, they'll roll back the changes. The challenge with these global services, and Front Door is a global service. We're going to talk about Traffic Manager later too. That's also a global service. Fortunately, Front Door has, I'm knocking on my desk, never had, or excuse me, Front Door has had several outages. Traffic Manager never had an outage. And we'll talk about, we're focusing in this architecture today that we're going to talk about on Traffic Manager, but you don't have to use it. You could use something else. So, John, you have a lot of customers that have customer-facing websites.
Yeah.
What are their thoughts on availability, and like how do they make those kind of business decisions around when to make things highly available?
That's a great question. I do have clients that are business or customer-facing with their websites, and the most recent, or the couple outages we're going to talk about, they were affected. So they actually were. For the most part, down and out while they were, Cloudflare and Front Door were trying to recover. Those decisions, I think, really come down to a matter of cost, right? So architecting high availability from, we always get the concept of, hey, we need zero downtime and zero data loss. We can do that, but the price usually goes exponentially up, right? Just give me your checkbook and we'll do it. So it's a matter of weighing cost versus customer satisfaction, right? Because if an outage, customers then get a bad taste in their mouth, loss of revenue, right? If I can't sell widgets online, then you got to balance that cost of the high availability versus how much revenue am I going to lose if I'm down for 10 minutes, half hour, 6 hours, 24 hours, whatever that duration is, and then make a conscious decision to do the right thing and put high availability in place.
Yeah, what's kind of interesting too about this architecture. So, full disclosure, I'm running this in my Azure MVP sponsored account. I am paying for the Cloudflare aspects of it. Fortunately, Microsoft changed our MVP sponsored account so that we can see the billing data easily now, just like a regular customer would. In this whole architecture is costing about $150 a month, and I think that's one of the things that's kind of interesting about it is. You can build with the cloud, you can build a lot of network high availability without spending a ton of money. There are some caveats there. There's a couple buttons I don't have checked that I would probably check in a production environment that would drive that cost up.
Yeah.
But it's not like, we're not talking doubling the cost of what you're deploying. Denny, what kind of architecture have you seen around like mission critical versus, non-critical workloads here?
Yeah, I mean, when it comes to mission critical, spreading the workloads out across multiple regions is, keeping things up and running. That's where you do your failover between sites and stuff like that. This is all stuff that we've all done for forever as IT professionals. Is we want to keep the thing up so we can keep selling widgets. And back in the day when we were all on prem, but pre-cloud, this would all cost you a small fortune to do. Cisco had like the gold standard and global load balancers, and they charged you accordingly when you purchased them. I mean, assume 6 figures US, if not higher, to buy the things. And now, like Joey said, like we can do this for a couple $100.
And then you have to, beyond that, you had to have multiple data centers to host servers in. And yes, you could go to a second colo, but it's still the hassle of, getting a server or set of hardware to a colo, buying that second Cisco switch that sits in the other location, and then even still, you only have two locations at that point. So you're still looking at some single points of failure. And John, you mentioned your customers have experienced downtime between these outages. Denny, have you had anybody go down, not necessarily even beyond these outages, but like in the last year?
Not that I can think of. I know I had a customer that was impacted by the Front Door outage because I had to walk them through getting their site back up in a fairly quick method. And it was because their site went down because of Front Door. And fortunately, that was a quick DNS change to make that happen. I don't, knock on wood, I don't think anybody else has gone down because of any cloud outages.
So once again, I mentioned this. I really do try to keep track of these cloud outages, and I really want to help customers understand like how outages happen. It is very rare that virtual machines, IaaS, EC2 instances, take your favorite name from your favorite cloud, go down universally. You might have some scenarios where they'll like a rack of servers will go down and your VM will be unavailable temporarily, or even for a few hours. Typically, what you're going to see is specific services in a region are going to go down. The recent AWS outage was driven by DynamoDB, which happens to be what their DNS uses. Had a major outage. There was an outage that took that service down, and you could no longer write DNS updates in Route 53, which is Amazon's DNS service. Turns out, writing to DNS is single home to East US 1A in AWS. Reading from DNS is global, so you can read anywhere, but the writes are all single homes. So that's a problem. And the DynamoDB aspect of that's a problem. And these are good questions to ask your cloud provider as to when you're choosing services, especially for critical applications, what are the dependencies? They may not tell you, like there are some things that are NDA, but it's always good to ask the question so you have some idea of, if you can understand where your single points of failure is. Because when we're talking about availability, that's always the question. What are the single points of failure?
And to keep that in mind, or something to keep in mind when you're asking those questions, is the salesperson might not even know.
No, you're probably going to have to get an engineer.
Yeah,
like, a lot of times.
In.
Yeah, I've done training for cloud solutions architects who are the sales engineers at Microsoft, and they're good, but I know frequently they don't have the same level of technical expertise we do as MVPs from working directly with the cloud product teams and such.
Yeah, I'd agree with that.
All right, let's talk about what Front Door and Cloudflare actually do, because I think people hear these names a lot and don't understand. Denny, let's talk about global load balancing and how that works.
Yeah, so the idea behind global load balancing is it's going to detect if a site goes down that's hosting your app, and then it will then quickly route traffic away from that site. So think you've got a copy of your website in North US and copy your website in, say, North Europe. So you have a global load balancer, like say Traffic Manager or Front Door or Cloudflare, looking at both of those sites as quote unquote independent endpoints. And then if one of those were to go down, it would simply stop sending traffic to that endpoint and send all the other traffic to the other side. So if, say, North Central had an outage or did maintenance or whatever, and the website went down in that region, your global load balancer would see that outage within 10, 15, 20 seconds probably, and route all the remaining traffic and all future traffic to, in this case, Europe, to be serviced there. And then when the website comes back up on this side, on the US side, the load balancer would then see that it came back up. It would see that it's responding with 200s if it's a web service, for example, and then send the traffic back to that to start handling traffic there independently.
Yeah, the next thing I'll talk about this is content delivery networks and caching is something else Front Door and Cloudflare do. And inherently, this is one of the reasons why Front Door is a global service and why the outages have been so bad when they happen. But I'm going to take this back to a story I had. When I was working, I used to work at Comcast Cable, everybody's favorite company. And we had this whole mess. We had a lot of messes around Comcast.com. We had a offshore consultant actually accidentally delete the SQL Server cluster one time. Oops. Because he used to work at Microsoft, and they did that all the time. But we were having some perf issues, and there were some database problems that I helped them to fix. But while we were having these broad meetings with all the architects in the room, somebody was like, "Hey, why is Comcast.com 35 meg?" Well, the answer was we weren't using a CDN. And if you're not familiar with a CDN, that acronym stands for Content Delivery Network. When you see fancy websites that have all sorts of images and videos playing, those images usually aren't hosted on the base URL. If anybody's got a pie hole and blocks ads from their network, they're probably intimately familiar how these work, because
Oh yeah.
the ads on pages also usually aren't from the base URL. They're coming from some other domain. So what a CDN does is, let's say DCAC or 3Cloud's homepage had a a 1 GB video. Instead of loading that video from the web server every time, it would be loaded through a CDN. And the first time you loaded the page, it would fully load, and it would probably take 20 seconds or something. But the next time, that file would be stored on a point of presence near you, typically in the nearest big city to wherever you are. Like if I look at doing trace routes, I can see Comcast has one in Philadelphia, and I know with things like Netflix and stuff, they put them in the cable providers all over the place, and that data gets cached locally. So the subsequent users are hitting a local cache, and most importantly, they're not banging against your web server, downloading all that data. Your web server is like serving effectively JavaScript pages that don't have a lot of rendering effort, and that's kind of how that works. One of the other services they offer is SSL termination and offloading, and this is something else to kind of reduce the load on your web server. John, SSL offloading, you correct me if I'm wrong, but that's like when the web server just decrypts the certificate, or a service decrypts the certificate outside of a web service, right?
I think so.
Yeah.
That's actually a question for Denny, because he's written 7 books on security.
Yeah. Yeah. So SSL offloading basically means that something before the web server is going to handle the SSL. So in this case, let's say we've got Front Door in front. So we've got Front Door here, users over here, as my hand disappears. And then we've got our web server over here. So if you've got really basic SSL termination, instead of putting the SSL certificate on the web server, what you'll do is you'll put it on Front Door instead. The users will SSL to Front Door, and then Front Door will do HTTP from Front Door to the web server. So that you can do all sorts of cool stuff in the middle here. This can be SSL as well, depending on what the requirements of the app are. But the way the quote unquote cheap way of doing it is move all the SSL traffic and decryption to this appliance, and do non-SSL from the appliance to the actual web server's termination. That way the web servers aren't doing all this extra work.
Yeah, and that lets us flip a bunch of things. Like we can do other things with that traffic and how we route it, because we're moving that on the edge. Yeah, and I saw a comment from the audience that we could do that on the firewall. And yeah, yep. Front Door is also kind of acting like a firewall, and that's a really good comment, because our the next thing I wanted to talk about was web application firewall security protections. What I'm about to say doesn't mean you can do bad stuff in your database and let SQL injection happen in your app. But one of the things the web application firewall does is monitors against SQL injection attacks. It also monitors against things like cross-site scripting. What are some of the other? Do you know some of the other attacks, Denny, off the top of your head?
I don't off the top of my head. I know
it's in the white paper that you can download. Yeah. But there's a list of the most common attacks, and I don't know what this acronym stands for, but I always remember it, called the OWASP, as in OWASP top 10, and it's the top 10 most common threats against security sites. So that's pretty much how websites commonly get attacked. The other aspect of this that is like a little bit of an elephant in the room is DDoS, and I find it funny because every time I see a Cloudflare outage report, and Microsoft has done a really good job on these outage reports with all these outages, but Cloudflare gets them turned like the next day. And I saw the CEO wrote one of them, which is a little weird, but it was deeply technical. So go CEO.
I thought it was a good report too.
Yeah, and they're like, we were not under attack during this outage, and it was like the second paragraph, and I was like, that's kind of impressive. And that was John. Did you read that report? It was just like some kind of configuration thing where they buffer overflowed, right?
That's what I understood it. Like it was a human error. They made a configuration change and it got propagated out, right?
Yeah. Yeah, replication. One of the things you'll notice in these cloud outages, and this is kind of an interesting thing to talk about, when you're building code at that scale, you have to automate everything.
Yeah.
And automation's really good at deploying a bunch of code all around the world. It's also really good at deploying bad code all
Yep.
around the world.
Which
And
Really,
that's
really, really
evident.
fast.
yes, so you can break your entire environment very quickly. And that's one of the risks with these global services, right? Like because you're doing that singular deploy, and I don't know enough about how Microsoft and Cloudflare do their deployments to these global services, but like ideally, what I'd like to see would be almost a second shadow beta set where they could do testing there. It's interesting, Denny. You said the last front door outage was caused by like a user invalidating entering invalid data or something, and that broke all of front door.
Yeah. So if you read the report on the most recent front door outage that happened, the second big one, the end result of the investigation as to what happened was some user or some Microsoft customer made some sort of change to their environment, and that put data in some config file somewhere and at the data plane, and that somehow broke the control plane that controls everything for all customers worldwide, including Microsoft's own properties. So Microsoft's own stuff like the Azure portal are running through Front Door. And yeah, that somehow that user was able to make some change and broke everything.
And that's a good segue because I want to talk about the Azure portal. And we're going to talk about this architecture here. And this is in the white paper we put together. This is the general architecture, and we're going to walk through this in both Azure and Cloudflare in a minute. But one of the things you'll notice here, let me grab my highlighter pen from my laser pointer from PowerPoint here. We have application gateways in front of these websites, and if you're deeply familiar with Azure networking, you may wonder why we have that, because it's application gateways are somewhat redundant at front door. They have a lot of similar functionality. Application gateways are single home to a region. We could put a lot more stuff behind a single application gateway than just one website. But the reason why I did this is in reading that Microsoft postmortem was that what the Azure portal did, interestingly, as soon as front door went down, they had the ability to kind of do this failover that we have here running through Traffic Manager, where they can route directly to each app gateway in front of each, presumably it's a web service or whatever it is in the portal behind the app gateway. They can route directly to that. But one of the things that was interesting was, even though there were two front door outages, and one, the Azure portal was down hard for several hours. I wrote about that one in Redmond. The most recent one, the Azure portal came back up pretty quickly because they were able to do that flip. But what was interesting was everything behind the Azure portal was probably still dependent on front door and mostly down.
Yep.
So thing to remember, it's not just always getting there, it's what's behind it. So it's not, especially when you start dealing with, not that any of us work on anything that's the level of complexity of the Azure portal, which is probably thousands of different systems. But the 2 or 3 different systems you may have in your web app, if they're dependent on some other resource, they need a failure path too.
Yeah, most definitely. That's one of the key things to remember is, like, if you're setting this up for the front end, any other component that has like a web call or REST call to another component within your app, that also probably needs this exact same level of complexity set up behind it. Otherwise, if, for example, in this diagram here, if front door were to go down, and you're using front door for everything else internally that you have to hit, now suddenly all those other things are going to not work, even though the front end of your app is actually working. You're going to lose functionality, you're going to lose downtime, customer confidence, and not sell widgets, which is the main thing we all want to do, is sell widgets.
Yeah, and that's a really good point. Like we kept this as simple as we could to better illustrate the networking. You wouldn't, because of the nature of the way Front Door, Traffic Manager, and App Gateway works, you could have multiple sites behind all of those things. Like we could spread this diagram out a lot, and your cost really wouldn't go up any. So that's kind of an important thing to understand. Once you have this infrastructure in place to be kind of fully redundant, uh,
It's pretty static.
you can add a lot more to it.
Yeah.
And let's just kind of walk through it. We'll go into the portal in a second and look at some of these details. But effectively, what we have is an app service website that's in two regions. So we're in US West and US East. You may notice, even though three of us are data platform MVPs, I don't have a database behind any of this, and I'll show you. Here's what the web service does that I have. It's really fancy. The reason why I did that was we were focused on just the network side of this, and we wanted simplicity. But if you were using Azure SQL Database, you might have an Azure SQL Database and a read replica behind each of these. So we're spread out across two regions. So I'm going to first follow this traffic manager path, which is traffic manager 2. This is if we were assuming Azure's up but front door is down. This would route all customers coming in to the nearest app gateway for the site. So we have each of these defined with a URL, and that would walk through. So we can split traffic that way. But the way we're generally splitting traffic, if everything works, is front door is going to load balance the traffic between east and west. Denny, do you know front door? Like, do you know what algorithm it uses to do that?
I don't off the top of my head.
You can configure routes. So I think if you wanted to, you could specify. But yeah, it does some load balancing. I'm not sure if it's round robin or priority or what.
I would assume it's priority or response time.
Yeah, that would be my guess. And so front door is going to route through the app gateways. We have Cloudflare as a backup. What we also are going to use Cloudflare for is DNS. So this site's registered with Cloudflare. So we'll talk through that. And let's just kind of go into the Azure portal and start looking at some of the resources we have. There's a lot. I hope everybody appreciates the name "Shut the Front Door." I put a lot of thought into this resource group name. One of the biggest challenges I had here was just doing certificates, and we're going to talk a little bit more about certificates after this. But I will say the hardest part of this was just getting certificates to work correctly across everything. We have a few things. Let me see what's on the second page just to make sure I'm not missing anything obvious. Okay, we have a front door web application firewall policy, which is just going to be our default. Let me make this a little bigger. You will note the location here is global. And likewise, our front door is global and our traffic managers are global. As I mentioned, we have two traffic manager profiles. We'll pop into the app service here. One of the kind of interesting things about this is we have to define domains at each level. We also have like default domains at each level, which makes this all the more confusing. So when you deploy an Azure App Service, you get a default domain of Azure Websites. If I see my custom domains, I can see I have sketchyracingsponsors.com. I also have eastus.sketchyracingsponsors.com. We defined a similar subdomain for West US. And the reason for that's like our health probes. And Denny, you kind of explained this well yesterday, so I'm going to defer to you to talk about why you do that way.
Oh, great. You want me to remember what I said yesterday? Awesome. I'll remember this morning.
Subdomains for health probes.
Yeah, so it's basically for the health probes. When you're setting up the health probes in any of these services, you've got to give them either an IP address or a DNS name. Well, if you give them an IP address when you're hosting things in App Gateway, the health probe will fail because the app gateways are not configured to respond correctly. They'll give you a 502 error or something like that. So you've got to be to a DNS name. Well, for these health probes to work correctly, they have to be a DNS name that's registered to that specific region so that you can make sure that it's routing to the right place. Well, now that you've got a DNS name, the SSL certificate has to match that specific name. Otherwise, you're going to get a certificate error, which is going to cause the health probe to fail. So all these things have to match up correctly. And the bonus of this is you can see where everything is actually going in, and you can test things specifically yourself because you've got a DNS name to go to.
Yeah. If somebody you could maybe argue this is a minor security risk, but you can see, like, if you open F12 and developer tools and you're looking at URL calls, you might be able to see, there might be places where you can see the actual domain name. But these are all public domains anyway, so if anybody was like Wiresharking their own network going to your website, they could see it as well.
Yeah.
Yeah, so all this is HTTPS traffic. We have a couple rules here. We also have defined Cloudflare, sketchyracingsponsors.com. That ties in. I'm going to navigate over to Cloudflare. Here you can see this is all the DNS records for this website, and we have a lot. Because of all these various resources, I've had to configure all these TXT records to various certificate, various Azure stuff. We also have cloudflare.sketchyracingsponsors.com. So let's navigate kind of back over to Traffic Manager. I mentioned we have two traffic managers, and I write more about this in the paper. But one of the things about Traffic Manager, Traffic Manager has a routing method. And the routing methods don't have great names. They're kind of confusing, even to us.
Understatement, yeah.
So priority means failover, effectively. So we have 3 endpoints for this. And what we do when we use Traffic Manager is we route our DNS name for our main website to this URL, which is tm-shutthefrontdoor.trafficmanager.net. That's going to actually resolve to sketchyracingsponsors.com. I think if I go to its configuration here, I can see my custom header settings that we've defined, and I have my endpoints. My first endpoint here is going to be Front Door. So if everything's up and happy, we're going to go to Front Door. If everything's not happy with Front Door, we're going to go to Cloudflare, and we'll talk more about how Cloudflare works in a second. The final, if Azure and Cloudflare both happen to be down, if Cloudflare and Front Door are both down and it's the same day, I think every IT admin in the world is having a really, really terrible day.
Yep.
But just in case, and mainly because the Azure portal kind of did something like this, and I wanted to be able to follow it, I named this incorrectly. So it's tm-shutthefrontdoor nested geo. I thought I wanted to make that geo. I did not. I was confused with routing methods because they're hard. I chose this to be performance. And what the performance routing method does is it routes you to the lowest latency connection to your IP address. I know we wrote training or did training on this, Denny. Do you remember how it determines that?
The service keeps a catalog of
Okay.
how everything's responding from all the various areas in the world, and it basically just looks up, I think, your IP address based on
Your location.
What /24 or /16 you're in, and go, all right, you probably should go to this one, and then it catalogs those and keeps track of it. If you're on a site that has usage as opposed to a demo site, that traffic view will show you kind of how the load is working.
Yeah, and so what we did here was we created a second one and we nested it, and that's if you want to use Traffic Manager with 2 different routing methods, that's the way you have to do it. So you have your first one, which is whatever your primary method is, and then your second one, which is in this case, going directly to the app gateways. And we're doing this because we're going to 2 different sets of endpoints, and we wanted to choose 2 different routing methods. But you can mess around with that for however you want. Also in Cloudflare, we have what Cloudflare calls a load balancer. And let me make this a little bit bigger. This screen's a little bit of a mess. But we have that load balancer. You can see it in the DNS entry. I went ahead and just made this a subdomain of cloudflare.sketchyracingsponsors.com because it made it a little bit more obvious. And kind of like the Traffic Manager, what it does, it goes directly to the Front Door. We can, with Cloudflare, you can quickly disable these things without many configuration changes. So like if Front Door went down, we could easily just disable this and route traffic directly to our app gateways. And that's using our subdomain. So you can see that. We also have host headers configured, which is going to lead us into our next topic, which is SSL and the really hard parts about this, because that is one of the challenges of why we have to do this. But this gives us 2 sets of load balancing 2 websites that are all sitting in Azure. You might ask, and you might ask, why do we have both of these websites in Azure if we're so concerned about all this network infrastructure? And my answer to that would be app service hasn't gone down that much. John, what are your thoughts on
I don't know of app services going down that I am aware of.
Yeah, I feel like we're trying to balance out complexity and cost, and mainly complexity, because like I mentioned, this frankly doesn't cost a whole lot. Some of the costs would increase with a lot of utilization, but mainly we're trying to keep it simple. Especially if we had a real app that wasn't just doing, this. Uh, Having databases across multiple clouds, or even if you had just your database in one cloud and you had to route network traffic to both of those, like it just that starts to get really messy. One of the things I do tell customers a lot is consider having a static web page at a second website, a second cloud provider, where you're basically just have a static page that says this is us. We're in a degraded state, but if you need anything, here's who you can contact. It's cheap to do that, and it's very very efficient in terms of configuration. You wanted to say something there, John?
No, I just think that's a good idea to have for clients to have a static page, just to have a presence when things do go down.
Okay, let's talk about certificates. So I built all this network infrastructure in about 20 minutes on a weekend, because it wasn't that hard. To get the websites to actually work took me a few days. The biggest problem was certificates, in making sure we all had the right ones. Part of this was a little bit of my ignorance of Cloudflare and the way their certificates work. Because if you're just using an app service, and this is kind of one of the challenges of this, app service, app gateways, and Front Door all treat certificates slightly differently, which is really fun. If you're using Cloudflare for your DNS and you have and you have a Cloudflare certificate, you can use that in app services. You can't use it in Front Door, which is a problem because Front Door requires intermediate certs. Denny, can you explain like certificate chaining, since you've written all the books on certificates?
Yeah, so the way it works basically is there's the root certificate up at the top. That's whatever company you're buying the certificate from. CA. And then your CA. So then at the bottom there's the certificate that you install on your web server. So that server certificate is not going to be signed by that root certificate. It's typically going to be signed by what we call the intermediate certificate that's in the middle. And that intermediate certificate is then going to be signed either by another intermediate certificate holder, another CA basically, or the actual globally trusted root CA. So when you go to deploy all this stuff, things like Front Door, not only do they want the normal cert you give the web server, they also want that intermediate cert that you can get from the CA that signs that first cert. That's the point in between the globally trusted root cert and you. They're going to want that intermediate cert as well, or that whole chain of intermediate certs, so they automatically trust how all this is supposed to work.
Yeah, the one of the things I'll say is me using Cloudflare for DNS probably made this more complicated. If you're working in Azure, use Azure DNS and use one of their certificate providers, because then kind of all this stuff happens magically.
Yeah. Joey, your mic died.
Technical outage. Cloudflare went down.
Fortunately, Joey has high availability for his microphones, so.
I do. So that was really quick. If you're, what I was saying before is, if you're 100% in Azure, you should really just manage your domains and certificates in Azure, because a lot of these problems I'm talking about are because I didn't just let Azure manage all that for me. Because if you have Azure managed domains, Front Door can deal with all that, and Azure can even do your cert renewals. I don't remember the two providers. Like, you have to use the two providers they specify, but that is one of the things you can have Azure do for you.
Yeah, it does make life much simpler to just let Azure deal with all this stuff, especially if your websites are all going to be hosted in Azure, and then you just take those certs and put them in Cloudflare.
Yeah, so to make this all work correctly, and this is where I kind of had some struggles, was Front Door, the app gateways, and the websites all have to have the same certs. And with all these subdomains, you can't just issue, like in our case, you couldn't just issue one cert for sketchyracingsponsors.com. You could issue one cert for that and then issue one for each subdomain. I ended up cheating a little bit and using what we call a wildcard cert. So it was for star.sketchyracingsponsors.com. It's a little bit less secure. I don't think it's a big risk. It's only a big risk if you're like IBM and you issue a cert for star.ibm.com. If you have kind of a narrow scope of what those wildcard certs are, it's usually not that much of a problem. And then DNS was pretty straightforward. You end up having a lot of CNAMEs, and you saw all the text records I have. The text records are just verifying that you own the domain for all these various services to be able to talk to it. One of the things I wanted to cover a little bit, and John, this is super your area of expertise because I know you've presented on it. Databases. We didn't have a database, but I just wanted to talk about like how maybe you would configure that, in SQL Server or Azure SQL DB or even MI for a customer if they wanted to support multi-region. What are some of the details you'd be concerned about?
Well, for SQL DB and MI, I would probably do a failover group for both, right? Because then we get DNS routing through the read-write endpoints. Probably, as you mentioned earlier in the architecture, I would have the primary in East. I'm assuming East is primary. And then have my readable secondary in West. And then the endpoint would be interesting. Oh, the endpoint's DNS, and isn't DNS global?
Yeah.
Yeah,
so
DNS
then,
is global.
So then it would just function even if we had an outage from Front Door or Cloudflare. Routing to the database would still survive. So
yeah, and if I remember correctly, Azure doesn't use Traffic Manager. They use App Gateway, I think, to route traffic or not Azure SQL database. Yeah, you're connecting through an App Gateway to that.
Yeah, I believe you're correct. It's through an App Gateway.
And yeah, go ahead.
For VMs, I do the same thing. Like I would stand up an availability group with a listener. And use DNS to direct that.
Yeah, for sure.
Yeah.
Like, and you could, depending on how well you understand your code too, you can send the read traffic. Like you can send read traffic from the West site to the read replica, as the case may be. Unfortunately, there's no notion of like Traffic Manager for SQL DB where you can route it to the closest one. But you can define read. Can you define read routes in failover groups?
I don't believe so.
No, you can't. You can't on VMs, of course, but
yeah, if you have a VM and you have availability groups, you can define read routes.
Sean actually made a good comment that distributed apps and architecture and distributed databases is a big design effort, and businesses need to realize what that effort really is and what it's really going to take to implement that. I think that's a really good comment.
I was told distributed systems were easy.
Just give me your checkbook or your Platinum Express, whatever you want to, whatever.
I will pitch in for an O'Reilly book I like, and I saw Sean mention Brendan Burns. There's an O'Reilly book called Site Reliability Engineering that's written by a lot of ex-Google engineers that talks about how they invented Kubernetes. There's a lot of really good foundational stuff in there about modern availability thought and like how it's okay to have things down. It's more that you need to be able to tolerate the failures and still provide some kind of user experience.
Yeah.
Clients with RPO and RTO of 24 hours.
Yeah. So one of the other reasons why I have App Gateway in place is, as I mentioned, this is all on my MVP sponsored sub, so Microsoft is paying for it. And I don't have this button turned on because it's an expensive button, but there's a button that lets your application gateway be a web application firewall. You could do that in Cloudflare as well. Front Door is going to provide that web application firewall experience, but if you turn it on an app gateway, you have to pay for it. Cloudflare can do that as well, but they also charge money for their services for that. So that was one of the reasons why I had the app gateways, but I don't have the fancy setting turned on. Denny, talk about DDoS, because Front Door handles that. App Gateway would need Azure DDoS associated with it, right? And you can have that per subscription, but it's expensive.
Azure DDoS is expensive. It is you need one globally for your tenant, but it's billed to a single subscription.
Got it.
So it's really weird and confusing, but you can put everything behind it: VMs, Azure Firewall, Azure app services, app gateways, whatever you've got out there can all go behind this one service. And it basically just stops people from DDoSing your site with just garbage traffic. All Azure services have a basic DDoS protection built into them. What the DDoS service gives you is Microsoft quotes as the enhanced DDoS protection. That does more, because basically they're going to do some out of the gate because they want to keep their network alive, and it's their pipes. So this just does more checks on top of that of the packets coming in. And we've got a couple of clients that are using it. It's a relatively good service. It is pricey to get into. I think it's $1,000 or $2,000 per month to walk into. But it gives you good info as to what's going on.
It is worth noting that you can DDoS a specific IP address. So if you only have a couple public IP addresses, you can.
I'm going to rephrase what you said. You can apply the DDoS service to a specific.
Sorry. Okay. Yes. Sorry. Sorry. Yeah. If you want to DDoS yourself, you probably could. But yeah. Sorry.
Yeah. Yeah. No, that's a good point. And I'll say Cloudflare has a similar service. So if you want to enable it there, you could do it there too. Compare prices, make a decision. Mostly, if you wanted to flip my architecture on its head and use Cloudflare as your primary and Azure as your secondary, you could also do that.
Yeah.
We have some questions from the audience that I think are pretty interesting, and I'm going to give the first one to you, John. I know you told me not to ask you too many questions, but I think you can handle. When is it worth investing? This is from Taylor. When is it worth investing in a multi-cloud, multi-edge architecture?
Oh, that's a good question. I mean, there's been conversations, and at least for many years that I can remember, of having some type of multi-cloud architecture to facilitate some of this stuff. That always gets more complicated and costly. If you are very sensitive to outages like Front Door and Cloudflare going down, and you need to be up online, I think it's easier with apps. When you talk about databases going across multi-cloud environments, that becomes significantly harder. There are some ways to do it, but it would be very complicated. And you have to evaluate whether it's worth that investment.
Yeah, and I think it's one of those things too, where if you're an IT manager or director and you're concerned about the availability of your sites, but you've struggled to get the budget to do it, right after an outage is the best time to ask for that budget.
Very much true.
Because your executives are like, why was the site down for 6 hours yesterday?
Yep.
Hey, Denny, where do organizations typically, and this is from Bob, underestimate complexity when building high availability web architectures? Is it networking, DNS, databases, or other?
I mean, it's going to be all of the above for the most part. People that haven't done a lot of this in the past, basically younger managers, younger directors, they've grown up in this world where they haven't had to deal with how to architect this because they're used to, being in the cloud and everything just kind of works for them. And then the fact that we're now talking about, all right, how do we address things that are failing that aren't supposed to fail? And we need to architect around them failing, and we have to do it while they're up. And testing, that's not really a thing we can do. Because we can't take Front Door down to test that our solution works. So we have to figure out a way to hack our way through this. So that's where I think a lot of these complexities of trying to figure a lot of this out come from.
That's a really good point. DR testing is something I see a lot of organizations not doing, including Comcast. But how do you test for disaster? And we kind of discussed this because we potentially wanted to do a failover demo, but it gets really complicated in a hurry. One of the things that's nice about subdomains and having that subdomain config is you can route directly to the subdomain, so you can potentially at least test your secondary path that way. but it's not like easy to simulate the failure of one of these things. And the bigger part in the cloud, because there's so much backend stuff, is you don't know what the downstream failures are going to be.
Right, yeah. Like if for example, Front Door goes down, what else in Azure is going to go down with it? Because it's offline.
Yeah.
So it's a weird conversation to have at that point.
And this is a good one from Brendan. If you could implement one improvement to prepare for global outages tomorrow, what would it be and why?
Ooh.
Oof.
And I'm leaving that open on the floor.
I mean, building redundancy at the network layer is going to be the big thing for something like a global outage, because the global stuff is all network based. So
Yeah.
Front Door, Cloudflare, Traffic Manager, DNS, those are all global services, and those are all at the networking layer. So building HA for your databases or your app or your website doesn't help too much if you can't get to the website at all. So
I'm gonna chime in with one before John says what he wants to say. I think it would be really cool, and this goes against the protocol, and if Kerry's listening to this, he's gonna shoot me. Being able to split a DNS registration across two providers.
Yeah.
It's not possible. You can't do that. It's not part of the way DNS works.
Right.
It'd be good if it could, you know.
Yeah, because like in the scenario when AWS, you couldn't write to DNS. If your stuff was in US1 and US1 only, you were down and you couldn't move it anywhere else if you were using AWS's DNS. So being able to split that, man, that would be kind of nifty. There's probably some ways you could do that with, like, if you had a secondary domain and then you use CNAMEs to reroute, but that's something that's really...
You could do it. It is doable. So if,
Yeah.
say, Cloudflare was your DNS provider, and you could set up the zone in Azure as a secondary option, and then in the event that Cloudflare DNS goes down, you then have to go to your actual DNS registrar. So whoever you don't register through GoDaddy, or don't register through Cloudflare.
Yeah,
register through somebody like a GoDaddy or something like that, and then just go to GoDaddy and go, all right, move my DNS so that it's my root server is now pointing to these Azure root servers instead of Cloudflare.
And 30 minutes later,
right? Yes. The caveat to that is DNS changes at that scale take time. And so it's gonna take a while for DNS caching to expire and stuff like that. So you're looking at a good hour or two before all that works, but there is at least a way to do it.
Yeah,
it might be faster than waiting for the other service to come online, though.
Yeah, exactly. Yeah, potentially. And frankly, that's always a challenge with disaster recovery, right? Like, when do you call it a disaster, and when do you decide to fail over? Because a lot. And I think we had this discussion with some attendee at past summit. People always still to this day get high availability and disaster recovery confused. Mm-hmm. When you fail over in high availability, no one should notice. When you fail over in disaster recovery, everybody's going to notice, and it's going to take some time. So when you're declaring a disaster, you have to, like, decide that it's time to move. We have one other question here. One I'll answer, and then one I'll share before we wrap up. What were the biggest real world challenges you encountered deploying Front Door and Cloudflare together? And I'll take it because I built this. I'm just going to say certificate hell. I assumed it would be a lot easier to do than it was, and eventually it was. Once I figured out that I just needed a wildcard certificate for everything, and then it worked. But I will say that the frustrating part about this from an Azure perspective, Front Door, App Gateway, and App Service all interact with Key Vault, storing certificates differently. App Gateway, I had to create a managed identity, which you can't do for the App Gateway side on the portal. You have to create a separate managed identity and then in PowerShell associate it with the App Gateway, because that doesn't work in the portal. Front Door has some really specific requirements around what you have to do with the Key Vault to let it in too. App Service, to their credit, that team has done a great job. App Service certs are easy, but cert management is painful. The final question we have, and this was one I had put together. and feel free to pitch this to directors and anyone else who's listening that's an IT manager. How should companies evaluate the trade-off of complexity versus cost? And I think it's not really complexity versus cost, it's complexity and cost when building multi-region, multi-provider architectures. I don't think the cost is a big element here. It's more the complexity. Denny, go ahead and start, and then John.
I mean, I would say the first thing to think about when trying to figure all this out is, do we have the staff that has the expertise to actually handle this? So say we're in Azure today and we're looking at moving to AWS. That requires a different set of skills from your staff and how to actually deal with it. And so do we have those people? Do we need to hire people? Do we need to train people? How are we going to handle the personnel aspect of it? And then there's the whole money aspect of it. Like standing up a whole new infrastructure in a whole new provider, that's expensive. Like building our environment in Azure and then building a secondary one in AWS is just going to be pricey. And now we've got two vendors we've got to deal with and all sorts of the fun that goes around with that.
John, your thoughts on that?
Yeah, so I want to tack on to what Jenny just said about pricing. I think a lot of organizations don't have any idea as to what the loss of revenue is for an outage. Right. So I think that if you have some notion of we're down for every hour that we're down, we're losing $1 million versus the cost of it building the multi-cloud architecture, or multi-region, whatever high availability you need for your application is $5,000 a month, right? You can do that math to identify that, but a lot of organizations don't know how much money they lose for an outage. Right.
They should just be able to go to their Fabric dashboard and check that out, right?
Wrong session.
You had to say the Fabric word, didn't you?
Yeah. Yes.
And so I think that's the biggest way to evaluate whether or not it makes sense, but organizations don't have that information. They're not looking at it. My organizations.
Yeah, I agree with you. I think it's having that understanding around the financial impact of the outage and being able to justify it. Because we're talking about all this fancy stuff, and right, if you have a crappy little website like sketchyracingsponsors.com, you don't need to be highly available. If your site's
you're
down,
not making the money to justify the expense.
Yeah, it doesn't matter. Your site's down for a little while, but if your site's bringing in thousands or hundreds of thousands or millions of dollars an hour, if you're Amazon.com, I mean, AWS exists because Amazon.com needed to be highly available.
Or healthcare, or financial, right?
Yeah.
All those silos probably need to be highly available, and they're making buku bucks, right? They're just raking in cash, right?
Yeah.
My blog does not need to be highly available.
Yeah, any global service, any global company that's selling global widgets or servicing customers in multiple countries, absolutely. I mean,
especially for there, but I think even in an enterprise like that, there are sites you're going to have that are can go down, but your main customer facing point of presence and where you're selling stuff, that stuff needs to be highly available. There were sites we had at Comcast that they could have been down for a while and nobody would have cared, but Comcast.com or payments.comcast.com.
Yeah, those need to be
those are important. Those need to be
those are important. Yeah. Well, we're at about time. Denny, you have the white paper on the website, so I think you can register and download that.
Yeah. So if you're watching us live, it'll be up there in a few minutes. I gotta click the button to make it live. If you're watching this recording, then it's live and it's available for you.
Yeah. So if you go to dcac.com and it'll be under media, I think.
Yeah, I think it's going to be under resources. There's a resources thing at the top. It'll be up there.
Yeah, you can download a white paper where we walk through this architecture in kind of great detail and some of the logic we put into building it and some of the other design decisions we made and how we built it out. With that, thanks for joining us and have a great rest of your day.
Thanks, everyone.
Thanks.
Bye.
Bye.
Ending event.